Good afternoon, everyone. Today we are going to discuss about the topic, the microwave engineering. We are going to see the few subtopics in the microwave engineering. First, introduction. Second, microwave devices. Third, microwave sources. Fourth, applications. So, in this topic, I'm going to brief and detailing about how this microwave engineering is going to play an important role in the day-to-day life and also in the scientific and also in the industrial purpose. First, there is an introduction. So, I hope everybody you have your mobile phones. So, what is the operating frequency of that mobile phone? Because without a mobile phone, we cannot be able to go anywhere today. So mobile phone, always we are having our mobile phone in our pockets and we are going to our office. Okay. So what is the operating frequency? 980 megahertz. Okay. That is generally speaking 800 megahertz. Another one is 1000. 800 megahertz. Another one is 1500 megahertz. Okay, it's going to, we have the two operating frequencies. Normally in the CDMA we will use some 850 like that. You can easily measure your mobile phone frequency in our college if we have a spectrum analyzer. Simply you connect a wire to the spectrum analyzer, and if you dial a call to a friend, it will capture your frequency. Okay, you can see the operating frequency of your mobile. So when this microwave engineering started, do you have any idea when this microwave engineering is commercialized? Microwave products were commercialized. So where it is initially used? So in the World War II, the scientists started experimenting their inventions like radars. The radars are used in the Second World War. Okay, they have started experimenting their inventions in the Second World War. So the microwave engineering is slowly used by the people. Okay, and later this can be commercialized. A lot of things can be commercialized, and ordinary people can be able to use a lot of microwave devices and the gadgets and everything. We will move to the topic. So this is a simple introduction, and it is the almost, you know, that all the communications. What is the relationship between the frequency and the bandwidth? Frequency and bandwidth. What is the relationship? If it is a 1 megahertz frequency, what is the relationship of the bandwidth? If it is a 1 gigahertz frequency range, what is the bandwidth?
Bandwidth is 10% of frequency.
Bandwidth is 10%. I am not asking a specific, what is the general relation between the frequency and the bandwidth? Frequency increases, bandwidth increases. Okay. So if the frequencies increases, why we are going for the gigahertz and terahertz? The main thing is we can able to transmit a huge amount of data in that particular frequency range. Okay, you know that the satellite communication, it is operating in a 2 gigahertz or 3 gigahertz. Okay, so why we are doing in a 3 gigahertz? Okay, because they can able to transmit the data in a huge amount of data in the increases more than 10 gigahertz or 20 gigahertz, okay, you can transmit a huge amount of data. Okay, whether you can able to transmit your high definition videos, you have any present technology you have to transmit high definition videos. So we are not having as of now we are not having a devices to transmit high definition videos. Okay, so the technology which is under the research level will call as YGIG. So that is going to operate in a 60 gigahertz. The operating frequency of the YGIG is 60 gigahertz. So this 60 gigahertz device can able to transmit the high definition videos. Okay, huge amount of data you can transfer. So the keep on we are increasing the frequency and we are keep on the increasing. There is a bandwidth can be utilized. More bandwidth is there. We can utilize. There is a one disadvantage if the frequency increases. What is the disadvantage? The frequency increases, bandwidth is increasing. It's a very good radiation. Not radiation. Distance. The distance between the source and the destination, because high frequency signals can be disturbed by the environment. Okay, you are not able to transmit a very long distance. If the frequency increases, the transmitter and receiver should be very close. Distance reduces. Okay, this is the general between this the frequency, bandwidth, and the distance. Now we will come to the subject. This is a general introduction how the microwave frequencies are used and where used. You know that today everything is going to become a wireless. So wireless convergence. So in a mobile phone, if everything is converged. Okay. So next, the microwave devices. So there is a lot of devices on there. EPT, HPTs, magic T, and we have isolators, and these are the devices which is used in the microwave system. Okay, before going to the devices, first we will discuss what is meant by a rectangular waveguide. So through the waveguide only we are able to transmit our signals. So this is a 2-port rectangular waveguide. So it consisting of the port 1 and port 2. Okay. So this is the first port and this is the second port. This is a 2-port rectangular waveguide. I am inducing the energy. The 100% RF energy is induced here. What happens in the output port? What happens? I am using the 100% of RF energy in the input port. Okay. So what I will get in the output port? What I will get? Whether I will get the 100%? Okay, we won't get the 100% of the RF energy in the output port. The sum of the energy may be absorbed by this rectangular waveguide. Some of the energy may be reflected back again in the first port itself. Only you will get some 80 to 85% of the energy in the output port. Okay. So this is a rectangular waveguide. So it is a 2-port device. If it is a 2-port device, theoretically speaking, okay. So far what we have discussed is theoretically. So always the engineering concept should be represented in the mathematical form. So we are going for the S matrix. That is the S parameter is used for the RF. That is used for the RF kind of devices. So S matrix is a 2-port device. So it is the S matrix S11, S12, S21, S22. This is the S matrix for this 2-port device. Okay. So if it is a port is 2, you will get 4 coefficients. If a port is 3, how many coefficients you will get? 9 coefficients. This is a okay. So what is this? Yes. S21. This 1 represents the input port and 2 represents the output port. Okay. We will continue in the next class.
operating range of microwave oven?
Microwave oven is the operating frequency is 2.4 gigahertz. There is a magnetron is used as a source. It is one of the tube which is a source which can able to generate. There is a power level is increased, so the food content which is inside the microwave oven is going to prepare. You can prepare the food. Okay, that is our 2.4 gigahertz.